Hi everyone and welcome to the Allplane podcast, where we talk with the movers and shakers that are redefining the future of commercial aviation. As usual, before we start, let me remind you once more that all previous episodes of this podcast, as well as many other aviation stories, are available on the Allplane website. That's Allplane.tv, Allplane.tv. Today on the podcast, an idea that is truly original, proper out-of-the-box thinking. Damon Vander and Andy Goessling are the CEO and CTO, respectively, of Magpie Aviation. If you haven't heard about Magpie Aviation yet, it is possibly because until very recently, just literally a few weeks ago, they were in stealth mode. In fact, it was so secret what they were working on that when I met Damon and Andy at a recent industry conference, they would not say what they were working on. Although some people in the know had assured me that it was something really, really cool. And indeed it was. Damon and Andy are reviving and giving a new purpose to a concept that has been around for quite some time. That is aerotowing. So what is aerotowing? Basically, a tractor aircraft pulls another aircraft through the air, and this second aircraft that is being pulled doesn't use its own propulsion. If you have watched classical Second World War movies such as The Longest Day or A Bridge Too Far, you know what I'm talking about. Because towed gliders were used extensively in the Second World War in order to launch stealthy airborne assaults like in D-Day. Well, Magpie Aviation is recovering that concept, but with modern technology and with a rather different mission. Basically, they are solving the problem of energy density of batteries, which is so limiting when it comes to aircraft range. And they are concentrating all propulsion power in one battery electric aircraft that is pulling the other aircraft, which is where the passenger or cargo are traveling. If it sounds outlandish, it is, well, because it is a little bit, but the Magpie team have done their research and have done very thorough development work on this concept. They have even tested it for real and successfully with a small-scale prototype. But you will have to listen to this episode to get the full details. You can be pretty sure that this technology won't leave you indifferent. So, without further ado, let me welcome Damon and Andy to the podcast. Hello, how are you doing?
Not bad. How are you, Miguel?
Very well. It's great to see you again. We met just, I think, about a month ago in Nice, the European Regional Airline Association Conference, an event packed with lots of interesting insights and very interesting people and companies. And that's the place where I heard for the first time about Magpie Aviation, which is the company you guys are leading and growing. At that time, it was kind of secret. I didn't know exactly what you guys were up to, what sort of technology you were developing. I only heard from a common friend of us that it was very, very interesting. And indeed, just a couple of weeks later, you went public. And I must say I was very impressed because that was something that is really original. I mean, I'm seeing all the time new projects, new ideas in the field of sustainable aviation and innovation in aerospace in general. But I must say yours was really, really one of a kind. So really grateful that you guys found some time to be here on the podcast and tell us a bit more about this project. But first of all, like every guest, I'm going to ask you to just briefly introduce yourselves and tell us a little bit more about your background and how you got into aviation and how you started this project.
Yeah, I guess I can start. So I started in electric aviation in 2009. I joined as an intern at this company, Magpie Power, that was trying to use tethered aircraft for power generation. You can think of it like deleting everything but the tip of a wind turbine blade. Pretty challenging business proposition. I had just been looking for something to do before a climate science PhD and ended up as the chief engineer and then as the interim CEO at the company. After my boss there died in the office, a fellow named Corwin Hardham, incredibly talented and very much before his time. We found a good home for that company and sold it to Google. I then ran it in Google for a few years. Again, challenging business proposition, but wonderful place to develop electric aircraft kind of competencies. After that, moved to Kitty Hawk Heaviside, founded that, and we built for a while, longest range, highest speed eVTOL, little single seater. We found there wasn't a huge interest from our investors in certifying the aircraft, decided it was time to move on and led me here.
Okay. When did you start Magpie, if I may ask?
When did we start?
in late December 2021.
Okay, so it's pretty recent. So, wow.
Yeah, not too long.
Very good. Yeah, sorry, I interrupted you when.
Yeah. So, I mean, my journey has been pretty similar. So I've been working in electric flying things for my entire career. My background's in electrical engineering. I was also at Makani and Heaviside. So at Makani, I developed the motor controllers that are on the M600. So it's the big 2 megawatt wind turbine that Damon was talking about. And then at Heaviside, I led the hardware team. So, responsible for everything that wasn't high level software or carbon fiber. So high voltage motor controllers, batteries, power distribution, triplex flight computer, air data, kind of that, everything that makes an electric VTOL aircraft fly, basically.
So Magpie, I don't know really where to start because it's, as I said, it's sort of it's one of a kind, but it's actually based on a concept that has existed, as you say on your website, that has existed for a very long time. Towing aircraft, having one aircraft, pulling another aircraft by, I don't know if you call it a cable, a rope.
Rope, tether,
Yeah. So that's basically how gliders get airborne. And even in World War II, in the Second World War, the gliders, that was a concept that was widely used, and thousands of soldiers were deployed this way with gliders that were being pulled by another aircraft, a C-47 or a bomber. And like in D-Day, there's this famous movie, The Longest Day, where that shows how a glider attack managed to take one of the key bridges so that the Allied troops could get through. And those planes were actually being towed by C-47s or bombers. So you are kind of recovering this concept. I think it's best if you explain in a few words how it works. Just in a few words, you will elaborate, but you have a hybrid electric aircraft that wants to go from point A to point B. But the problem is that the batteries right now, they don't have enough energy density to make long distances. So what you propose is that this aircraft takes off, it flies for a while, and then when it's in midair, it's met by another aircraft that it's packed with batteries. And the two aircraft connect, and the aircraft with the batteries, which is a fully electric aircraft, then pulls the other aircraft part of the way until it's closer to the destination, and then they disentangle from each other, and the hybrid electric aircraft ends up landing on its own power. And that way you extend the range of the hybrid electric aircraft. So can you tell us a bit more about that? Because I'm really fascinated by this.
Yeah.
Maybe start with the motivation.
Yeah. I mean, let's start with the motivation and with, kind of an analogy. With electric cars, I think we're aiming towards 20% of global sales being electric this coming year. So they're really taking off. They're becoming very cost competitive. But for them to do so, people had to find a way to get range when you want to go on a road trip, when you want to drive longer than your commute.
Indeed, I had this experience recently. I had to drive, had a long drive ahead, and it was a small car, not the car with the most range out there in the market, but actually I didn't make it on time because I had to stop a few times to
charge.
to recharge battery. So I know what you're talking about.
Yeah. So, with electric cars, with the ones that do charging really well, which unfortunately is only probably Tesla at this point, when you want to do a road trip, you have about 3 hours of range before you have to stop and charge. And then the charging can be, 30 minutes. So it actually works very nicely to have a supercharger network to get you your range. When you're building an aircraft, that kind of stopping and charging when you might, want to take a bathroom break anyway, that doesn't really work because one, your range out of an electric aircraft, it tends to be about the same, but you're going faster. So it's like an hour. And if you have to stop and land every hour, you give up the whole advantage of flying just because of the cycle time, getting on the ground, taxiing, plugging in, all that. It really is a lot more than for a car.
Yeah.
So basically, our approach, starting from the fundamental assumption, battery electric, because it's far more efficient. It's the clear winner in the space. It's the leading technology for any industry where it's kind of feasible. Battery electric, you need to find some way to get the energy to the aircraft to get the range, because the batteries, they're getting better at a moderate rate. So there's no magic battery out there probably that's going to just get you the range.
We're going to have an expert
Yeah.
in batteries here in
Yeah.
the podcast just in a matter of days.
Yeah.
So yeah, you're
Great.
right. Still,
Yeah, wonderful.
Some advances, but still a long way to go.
Yeah. But if you say, they're going to get better at a gradual rate, maybe the same 7%, give or take, that it's been over the last 30 years on average, and they're going to get cheaper at a continuing pretty impressive rate, which has been about 90% price drop per decade over the last 30 years, then you come to the conclusion, battery chemistry won't save us. Batteries will be the cost-effective option, but you need some way to get the range. And that's where the towing concept comes in.
I have a few questions. Well, quite a few actually. This system would require a degree of coordination between two elements here. One is the aircraft that is carrying the people or the cargo, and the other one is the towing aircraft. So first of all, you're designing the system that would connect both. How much of this whole system are you designing and getting involved in developing? I'm assuming that some of these aircraft could be just a conventional aircraft that can be adapted, and also the towing aircraft that it's going to be basically like a flying battery. Is this going to require a specific design, or you're going to adapt an existing airframe and then fill it with batteries and just connect this sort of connector mechanism between the two, the cable and this system that it's a bit like the air refueling. So when you see the images, it reminds you a lot of what the military do when they have to refuel midair. Even if in your website you say that it's easier. I'm not an expert, so I don't know exactly how does it work and how it differs from the mechanism used by the midair refueling.
Yeah, I mean, we can, to start, like back to your first question, which piece are we working on, right? We started by focusing on what we see as like the most novel and new technology, which is how do you connect aircraft in air easily, safely, and reliably. And that hasn't, to our knowledge, been demonstrated before. So the thing we did in March, where we hooked up our PIC 20D to our Pipistrel Virus, that was a world's first, and that consists of the probe that you put onto the front of the payload aircraft, the winch and tow line system you put onto the back of the tow aircraft, and what we call an active hook, which is at the end of the tow line. It looks a little bit like an aerial refueling drogue, except that it's actually has its own avionics and its own controls such that it can position itself directly in front of the payload aircraft. So, for example, in Navy operations where they do probe and drogue refueling, there the pilot of the jet aircraft of the fighter is just manually flying it into the drogue, right? And if you see videos online, it's not an easy process, especially when you've had to do it 8 times and you're 10 hours in or whatever.
Yeah, you show this video on your website. It looks really smooth. I don't know if that's because you have a very experienced pilot, or is because of the system is so smooth in doing that.
Well, it's because the system it looks almost surreal because the active hook doesn't move in the frame of the video relative to the payload aircraft, but that's not because the payload aircraft isn't moving around. It's just that the active hook is following it no matter where it goes. So, if you hit a vertical gust, the active hook just goes up with you. If you translate left or right, it just follows you left or right. And so the pilot isn't having to control any lateral or vertical positioning. They're purely responsible for monitoring the closing rate between.
One of the things I'll add just on the degree of coordination and working in the airspace is, a nice proof point for this is that we're able to go out and do it today. So I think it sounds very different to people than typical commercial operations today, because it is, but it's not that typical not that different from typical operations in the airspace today. It's like we go out and we do practice rejoins, and we're able to go out and get off tow, get on tow, and basically make every element of the system work now, which we think is a pretty big proof point that we could do it, commercially someday.
So then you're focused on the connecting system between the two aircraft. And then are you planning to get involved in designing
So
some element of some of the flying elements? So the one of the two aircraft that are flying, or that would be something that could be retrofitted into an existing aircraft?
yeah, so we're basically doing everything in a way where it's possible to do with retrofits. Obviously, with battery electric, just the way that the aircraft has to be built for a very efficient battery electric, you do end up wanting to eventually go to new builds. But part of the value of the system we're doing is that it works well with retrofits as well. So just for example, we've baselined internally a 19,000 pound which is, the top end of Part 23 of, small aircraft. We have baselined a 19,000 pound aircraft design working with Neil Wilford, who designed the Sky Courier, which, as you'll know, is a 19,000 pound cargo aircraft. Mm-hmm. So a very similar design problem. And we basically used our reference design there of what is a very practical, certifiable Part 23 aircraft for a tow plane to drive a lot of our longer term calculations. Now, will we build that someday? Our hope is not, in a way. Like the ideal scenario is that we see all the other players in the space come along and we make our little tow system. But the optimization for an electric aircraft is very different. So we're certainly considering whether that's a path we'll go in the long run.
I'm just thinking here whether someone has tried to basically pack an aircraft with batteries to operate as a towing aircraft. I don't know if there's any precedent or anyone that has.
Well, most electric airplanes to date have very few seats, so you could kind of say that's already what they're doing, right? I mean, I think that the real big difference would be the cabin volume, right? If you don't need to put people in, people they're not very dense. So you need a lot of volume for the given payload. So if you were to design a pure tow plane, you wouldn't need that cabin volume necessarily. And so that would be one difference you would see.
But is it that easy to replace, let's say, people with batteries? Because I guess there are like thermal and volume and weight issues here to consider. And the regulators also would like to have a look at that, how much battery you can pack in a specific cabin or something like that.
That's actually one of the nice things about this towing approach is you have the new technology, which the regulators, rightly so, are being cautious about introducing into commercial service with passengers on board. And you put it on an aircraft that doesn't have passengers. And to add on top of that, that aircraft also doesn't have to fly over populated areas because you pick up your tows, say, just to use a local example, over the Central Valley, not over, the more suburban Bay Area. And that doesn't mean you should cut any corners, but it does mean that you have a lower stakes option for how you introduce that technology. And we think that's a nice attribute of what we're doing. Mm-hmm. So then your tow plane can be much easier to certify aircraft. It gives the regulators some peace of mind, and your payload aircraft can be, for example, still a retrofit of something that's been around for a long time. It's much cheaper to get to that end result as well when it comes to certifying something.
And here there's another element that I would like to discuss is basically in your system, you would have the passenger or cargo aircraft departing from, let's say, a conventional airport, like the ones we have now. And then midway through the route, it will be met by this other aircraft that will be departing from another airport. You say one of the elements that make it possible for this system to have a relatively low cost is that this towing aircraft would be based at airports that have low traffic, low fees. But still, there's an element of coordination here. And you will still have two flying things to do what previously was done by just one aircraft. So the question here is how you coordinate this. Do you plan to get involved as well in the coordination, or that's something that you envisage operators, other companies doing? What's your role in this?
So we've seen different levels of interest from different operators, where some prefer to be the kind of full service provider and some prefer that the towing is a service. And that makes sense. And you can think that economically also, if there are a number of operators in a region, it's more efficient to run one combined tow as a service system versus if there's a sole operator who's doing this, it's probably more efficient for them to keep that in-house. So we're adaptable to both models. You are right. Now you have two aircraft in the air. When you compare it to just using a baseline electric aircraft, you can think of it a lot like flying two aircraft at half the weight each. And we know that, it's not as if flying in a 737 costs twice as much as flying in a 777, even though one is half the other, roughly. It's, you pay a slight premium to have those two aircraft, but, that's basically made up for by the fact that for longer routes, we're able to get the unused battery back on the ground and charging it.
Mm-hmm.
I think we talked about, just to bring up an example, we talked about a single tow. But one of the attractive things with this technology is that you can do multiple tows. So single tows are attractive when you're trying to do, just to give an example, it's a great way to go back and forth between two regions where you might be able to fly into all the little airports in, the San Francisco region, all the little airports in the LA region with only two airports that are set up for charging for the tow planes.
Mm-hmm.
So that's a very nice low infrastructure way to start going back and forth on electric. But then with multiple tows, that's basically where you see the big dividends. And that's the reason that, it really becomes worth it, is that you can do with multiple tows, you get the unused battery back on the ground, you get fresh battery up in the air, and you can fly routes that are much closer to that average of 1,000 miles. With three tows, you can get to the 1,000 miles. You can fly routes that are meaningful from an emission reduction standpoint, and not just kind of nibbling at the edges of, a percent here or there on these kind of oddball short routes.
There's a coordination layer of complexity, though, because you would have, it could be either one company operating both elements or separate companies, but also other elements. What happens, for example, if there is bad weather in one region along the way, but not in the other, at the both ends of that route, or
that's why it's a good fit for hybrids. So if your main aircraft is a hybrid, you can carry liquid fuel reserves, which are lighter, and it makes the whole thing more efficient. And then if you miss a tow, you can also make it through that missed tow leg on fuel. So let's say you are operating that way and you miss 1% of tows, which would be, you're not doing great at that point. That's basically immaterial from an emissions and cost standpoint. Mm-hmm. So we think that in that way, you can get to practically 100% of emission reduction, but not really have to pay for the intermittency problems that could come up, for example, with weather like you cite.
That's why you wouldn't really move past 4-ish tows, right? Because your mission reliability goes as like the
because
every reliability to the N.
Every step introduces even if it's a small element of uncertainty, adds up at the end.
So that's why we see this, the achievable range scaling from 1,000 miles to, forward with batteries getting better, right? We don't think this would be a very good fit for, serving 2,500 mile flights today.
Mm-hmm.
Right?
And up to which size of aircraft can you scale this system? How big can the towed aircraft be, and also how big and powerful can the towing aircraft be under this system?
That's one of the nice things. I think people often cite size limitations for electric aircraft, but those are only really practical from the average speeds of those aircraft. There's not actually a scaling limitation as to how big you can go on electric. So with towing, the towing technology itself, it's roughly sublinear. Like it actually gets a little easier as you go bigger. But with towing, you enable basically the electric aircraft of any size to have commercial value. So we don't really see a place we'd have to stop. I mean, there are electric machines that kind of match the size of anything out there that you'd have to deliver. So it's an integration challenge, certainly, and a certification challenge to make an electric 737, but there's not some fundamental limit.
You mentioned in your website that your cost of operating this system would be similar to the baseline cost of operating, for example, I think you mentioned specifically an ATR 72 turboprop aircraft. I think you mentioned a number. It's basically 20 cents per average seat mile as a cost of reference. And your system might be slightly higher, but not too much, and cheaper than flying with SAF or with hydrogen. So can you elaborate a bit more how you come up with these numbers? And
Yeah.
what are the driving factors here? Because as we mentioned earlier, we have more aircraft to coordinate to staff.
Mhm.
But then I guess, well, there are savings or the fact that one of the aircraft is not actively consuming energy during part of the route. What are the elements here contribute
Yeah.
to this cost
So
equation?
I can give you some of the assumptions that go into that one. We assume that electric propulsion will end up at roughly half the maintenance cost of gas turbines. There's a good reason to believe that. They don't get hot. You're not trying to operate it right, a little bit above the melting point of the metal in the device, which is what gas turbines do. The battery cost, we basically project it forward to 2030 at the trend of the last 3 decades to get to that number. So, continued improvements, but nothing groundbreaking. We assume that each aircraft, you have these 2 aircraft, which are each a little smaller as compared to, building an electric aircraft. And we assume that they basically cost like 2/3 as much for the tow aircraft as for the payload aircraft. You don't have to put in the it's kind of like a freighter conversion a little bit, in that you don't have to put in the seats and cabin, and you don't really need a lot of the systems involved with keeping a bunch of humans alive and happy in there. So I think that that's kind of a reasonable range to be in. That's kind of the simplistic view, right? So your energy cost comes down, your maintenance cost comes down, but now you're paying for some extra pilots and you're paying for, some extra aircraft. And so it adds up to a little bit more than today, but comparable. We've also done a much more thorough analysis where we look at, actual block time costs on ATRs, and we do the breakdown of an airline, working with a consultancy, Aviation Economics in the UK, to make sure we're, doing that accurately. And that comes to, by and large, the same conclusion as the simplistic model. So hopefully that gives you some intuition for how that pans out.
The end result is kind of an unintuitive result, right?
Yeah.
It was actually something that we kind of prevented us from starting this company for several months, because we kept thinking, oh no, like our spreadsheet must be wrong, right? And we would go in one level deeper and look in more detail. And then finally we hired a consultancy to check our spreadsheet and make sure that we weren't, drinking any Kool-Aid, or at least too much of it.
Yeah.
And, in the end, we just kept finding that this unintuitive result, which is like it turns out you end up kind of on parity with Jet A, right? Which even parity with Jet A is a lot cheaper than SAF, for example.
Mm-hmm.
That's another way to think about it too. Sorry, we've rattled on for a while about it, but it's like battery electric is on this amazing cost curve. So eventually it's functionally free. And at some point you're willing to do, a little bit of operational, hassle to get a fuel that's just on a totally different, cost scale than the alternative.
Mm-hmm. And as Magpie Aviation, what's going to be your business model? Are you going to be selling these kits, conversion kits for operators that want to retrofit aircraft? Are you going to license this technology maybe to OEMs? What's the plan here?
We basically, at every juncture, err on the side of building the most focused business when that's available, as our kind of foundation. But we're not afraid of expanding into operations if we see that as valuable. So sorry, that's not a very specific answer, but building the STC kits that's the minimum that obviously has to exist. And then we think about adding on chunks to that, basically where we see the rest of the industry having a gap, right? Mm-hmm. We have no desire to get into parts of the industry that are already done, frankly, very well by existing operators.
What about certification? Have you been talking with the FAA about this? And what do they think?
Yeah, I mean, we've been talking to the FAA since we basically started. We had our first meeting, we said we started in late December 2021. We had our first meeting with them, I think, in February of 2022. So a couple months later, we've had existing relationships with them from previous companies. And so we're actually a program of record in CECI, which is a program they have at FAA where you get to engage subject matter experts before you actually submit for your TC or STC. And so we've had meetings with ATC, with aircraft standards about this technology and some of the hurdles that will be there, and kind of engaged with them to understand kind of what they see as difficult and try to kind of adapt our approach accordingly. One thing I should mention about the regulatory front is there's actually already FAA ATC procedures for doing IFR refueling in civilian airspace. Okay. So when the military flies in civilian airspace, they use what's called MARSA, MARSA procedures, which basically are procedures for ATC to bring two aircraft separately together. And then when they're refueling, they're flown basically as a single unit in ATC's eyes. And then when they're done, they split back off and ATC assumes responsibility for them separately again. And so there's a good framework in place to kind of build upon for using that in civilian use cases.
Okay, that was kind of my next question. The implications for ATC of having all these couplings and decouplings in air and all these different elements that are operating separately, but at the same time coordinately. Is the public opinion prepared to fly this way? Are you planning to start with maybe cargo first, or you just see passenger transportation as the primary goal here? For example, part of the public, they already have issues with turboprops, for example, which is a perfectly sound technology that it works perfectly well, but they somehow associate that with legacy, old aircraft, whatever. I'm just trying to picture here how people will react if they notice that they are being pulled by another aircraft and they are gliding, basically. I don't know if you have given some thought to that and looked into this matter.
Yeah, I mean, our take is that consumers are actually pretty intelligent. And, you know, for example, with turboprops, I don't like flying in turboprops because they're loud, right? Mm-hmm. And one of the advantages of our technology is that if you're on, you know, if you have to work with an open propeller aircraft to start, given, you know, the low density of some of these sustainable fuel options like, you know, hydrogen and electric, if it's quiet for most of the trip, that's kind of nice. And that's something that we can provide.
Yeah, I was about to say, the experience of being in the aircraft that is being towed, how is it going to be? Is it going to be, I guess, quiet because there is
have you ever been in a glider?
Never.
Have you ever flown on a glider? Oh, okay.
Never.
Well, it's really interesting. You know, you've probably seen the GA pilots, they all wear the big headsets, right? Because it's really loud and you need those, right? And then you have a boom microphone. In a glider, there's just a speaker on the dash. And then you have a little microphone that just is like on the dash. And you can just talk like a normal talking voice, right? Because it's just really quiet. And, you know, the same would be true when you go to a low, a low thrust or a zero thrust state in those turboprop.
You can even make it like a selling point. Like on one hand, some people might be reluctant because of the whole setup. But on the other hand, I guess an operator could market it as the quiet way to fly.
Yeah. People might not like it conceptually, but I think people also don't conceptually like being in a, you know, pressurized metal tube that's like, you know, 1/8 of an inch thick, surrounded by a giant pile of flammable liquid, which is how we fly today. And so I think at the end of the day, it comes down to proven safety. And I do think consumers are pretty smart about that. It's proven safety plus basically the actual experience. Is it a ride likely to give you motion sickness? You know, on towing, it's not really any different, so it's not going to change for that. Is it loud? You know, it's quieter for us. So our suspicion is that that's not really going to be a barrier.
I mean, for the passenger, the only way they would know they were being towed is that it gets quieter.
Okay.
I mean, you can only look sideways, right? So you can't actually see. When you come on and off tow, their forces are negligible, right? If it might feel like you maybe hit a tiny bit of turbulence, like very light.
How long is this towing line?
Right now, we're flying on a 100-meter tow line, but when you get up to commercial scales, a lot of the designs end up around 1 kilometer.
1 kilometer.
So the aircraft are actually pretty far apart. Wow. And this is what's enabled by mechanical towing. And you could also consider recharging in air, for example. There's a lot more equipment involved with that. A lot more can go wrong. And, you know, that cable is a lot heavier. So as much as we draw the comparison to aerial refueling, we actually get a lot of advantages over aerial refueling from that large separation.
Mm-hmm. And of course, the towed aircraft will always have the option of restarting the engines and fly on its own power. But what happens if there's some issue with the towing line, the hooking mechanism? Is there a way to uncouple that mechanically in some way? Because I'm thinking one potential risk, I guess you guys have thought about that already, but is that they cannot separate, and I don't know, something happens with the first aircraft and it just pulls the other along. So if you are in the towed aircraft, how do you solve this issue?
This is a problem that's been solved by gliders a number of times throughout history. And basically, you have a way to release the tether at the towing aircraft. Mm-hmm. You have a way to release the tether at the towed aircraft. And then you may have an additional redundant way to release the tether from that active hook, the thing that makes a connection at the towed aircraft. Mm-hmm. So we have, with safety, it's all about having enough safeties, but not too many. You want enough to get the level of reliability you need, but you don't want too many that will, add complexity where you can get unexpected interactions. So just like, twin jets, you could ask what happens if that second engine fails? Well, each one can be built reliably enough that it functionally doesn't happen, not for reasons that would be solved by having more engines, certainly. So it's the same thing here, where each of those releases can be reliable enough that you're not going to, blow through all three somehow.
And where are you now with the development process? I've seen on your website you have a video that you've been of the testing you've been conducting with a small aircraft, which you have managed to successfully link up in the air and having one pull the other. But I guess that's only the initial stage. What's the time frame for this technology to be certified and to become commercially available?
Yeah, so we're not putting out a certification timeline yet, but we can say that this is an STC, and a typical STC timeline is 2 to 3 years. This is probably a little above typical in complexity. Whereas a typical certification timeline is more like 3 to 5, with actually quite a number of programs do end up overrunning the 5. So we think it should be faster than certifying new aircraft. As to where we are today, we were surprised by our last round of flight tests. That was actually the first time that we had gotten a reconnection in flight, when we'd finally proven all of the technology through our ground testing and we're ready to try it. And it worked far better than we expected in the air. So now we had expected at this time we'd actually be doing a lot of fine tuning, but now we're basically moving from that initial point of making the core technology for connection work onto scaling it up, which it actually doesn't really get much bigger. It just gets to be more robustly built, So I guess I shouldn't even say scaling it up, robustifying it for commercial operation, which we can actually test at our current scale with a current aircraft for anything up to a 19,000 pound capable tow device. So we're robustifying. We are working on the range of test conditions, where we go from just like on a light turbulence day doing solid connections, to doing it in rough conditions, to doing it at night, to doing it in simulated IFR conditions where we have a safety pilot,
because that first test was in March. Yeah. So
yeah.
Okay. That's pretty recent.
So so it's a little over a year for us to get from kind of starting work on a prototype scale to successful connections.
You're based in the Bay Area. The company is Magpie is based in. Okay.
We're based at Hayward Airport, which is one of the larger, longer runway, non-commercial airports in the Bay.
Okay.
Other part I'll mention that we're doing right now, we're actually working on an electric tow plane as a demonstrator. And the crazy thing about it is, if it hits its specs, it will be the highest payload range demonstrated with an electric aircraft to date.
Wow.
When you see it, it'll be smaller than you expect, is how I'd put it. Shows off some of the magic of towing. So we have that coming together, so we can really do the whole thing at this current scale, not just with a gas tow, but do it right with electric tow.
But are you retrofitting an existing airframe?
Okay. Yeah, it's a heavily modified existing airframe.
Okay.
In obviously we also need to get up to higher speeds going forward, higher speeds and altitudes. So we're starting to move into that, but we're gonna, kind of we don't have anything to announce on that front yet, is how I'd put it.
Okay, we didn't talk about speed, but the sort of speeds this system can support, are they very different from the ones that an aircraft would achieve by flying on its own?
How to put this? So we haven't looked at transonic flight yet, but the designs we're working with are pretty good up until you get up to where you really have to think about Mach. And so that covers the turboprop range pretty well.
Okay.
Yeah. Now the one we're flying, that's a demonstrator. So obviously, there's some robustification to turn that demonstrator into a prototype, and then turn that prototype into the certification intent article.
Mm-hmm.
But as for the fundamental technology, there's not really a speed limit until you get up to that the Mach number issues.
Mm-hmm. You are a startup company in the best tradition of the Bay Area. Did you get venture capital, or how are you funded? Is it privately funded by angel investors or something like that?
Yeah, so we're funded by a combination of grant, contract, we're being paid for delivery, and equity investment.
What do you mean that paid for delivery?
Oh, for example, we have an Air Force contract where we're paid for deliverables to them.
Okay. Okay, so there's some government research money as well. Okay, makes sense.
As is typical, you're trying to you gain something from each of these routes of funding, and it's smart in any startup to find the way to get each in your pipeline.
You had this big announcement just a few weeks ago. What's the next big thing that we should be looking for?
We're really big on talking about what we've done as much as possible, more so than what we're going to do. So I don't think we'll have anything to say right now, but I think there'll be some exciting stuff coming up.
Yeah, I mean, that was part of the reason you mentioned at the top about how it was secretive, right? And that was really a lot less, like we were talking to all kinds of people about what we were doing, but we weren't really being very public about it because we've seen a lot of renderings and other, talk of what people will do in the future, right? But we really wanted to make our first introduction to the world is like, here, we did it, right? It's done. Here's the video. And so that was kind of, a core tenet of what we wanted to do with Magpie. And I think we want to continue that.
Yeah, no, definitely. It makes sense when you hear it for the first time. It might sound outlandish. I mean, wow, fascinating. But you need to see it on a video to understand it. I'm gonna post a link on the show notes so that people can go and check and see all this process, because you have this camera that is showing just the moment when this cable links up with a towed aircraft. That's really, really amazing. So yeah, for people that want to learn more about you guys and about what you are doing, I guess they should go to the website, which is Magpie.
They should listen to your podcast, right?
Yeah, of course. Yeah, that's the first, the first step. But then I think we should send them to magpieaviation.com. You have a nice website. It's not overwhelming in terms of information, but you've got all the essentials, and there are the videos and a nice description of what you guys are doing with maps and graphs and all sort of visual resources to help understand what you guys are up to.
The other place to look for us is on LinkedIn. We put out a couple blog posts on LinkedIn, and we're going to probably continue to do that just to explain some of our thinking about the sustainable aviation sector.
Yeah, we see it again, a fair bit of hype in the space. So we're trying to, put out enough information to explain how we reach the positions we reach on, battery electric being a clear, kind of the technology to really focus on moving forward. I wouldn't discount the other ones, to be clear. Just, this is where I think we're kind of criminally under-resourcing the winner on the ground, so to say, for cars and trucks, right? As far as aviation goes. Why, aviation emissions matter, why you can't just ask everyone to stop eating meat and keep flying. It doesn't work in the real world. What extra, effective emissions come out with aircraft, because you do also get contrails from Jet A and other liquid fuels. So we try to at least put out enough information that people can get a sense of where we're coming from, and it's not they don't have to take a guess.
Well, wishing you all the best with this project, and yeah, I'll keep an eye on all the news that come out, because that's definitely one to keep an eye on. And hopefully we'll be able to fly in this very ultra quiet way in the future. That's going to be quite a thing.
Yeah,
Definitely.
Yeah,
Right.
well, thanks for taking the time, Mikkel, and for the excellent questions. And we'll be following your podcast.
Yeah, thank you very much.
Take care.
Before you go, and if you like this podcast, a quick reminder that it would be absolutely great if you could please give it a rating on Apple, Spotify, or whichever platform you're using, or recommend it to a friend or whomever might be interested. Thank you very much, and see you soon.